Hello, let's begin the session number 22, Deadlock Avoidance. So in this session we are going to see what is how we can avoid this deadlock, that is deadlock avoidance, safe state avoidance algorithm, resource allocation graph, bankers algorithm, safe and unsafe states. First of all, we are going to see what is the and how we are going to avoid this deadlock. So deadlock avoidance, it is better to avoid a deadlock instead of taking action after the deadlock has occurred. Meaning of what here? Before the deadlock happen, we need to avoid this deadlock should not be happened. For that purpose, we are going to avoiding. It needs additional information like how resource should be used. Means what here? The which process will going to holding which resources. That additional information we need to collect. Then after that, the deadlock avoidance is the simplest and most useful model that each process declares the maximum number of resources of each type that it might be needed. So it is easier than which resource needed, which process is needed, which resources. It is a very easy to identify it. So here a required deadlock avoidance requires that the system has some additional prior information available. Some prior information available in the sense of what here? The which process want which resources, that those all information we need to find out first. So simple and most useful model require that each process declare maximum number of resources of each type that it may need it. So here what happen? It is a very easy. Whenever the process declare the maximum number of needed resources, then it may be easier for avoiding the deadlocks. So second point, the deadlock avoidance algorithm dynamically examine the resource allocation state to ensure that there can never be circular wait condition. So means what here? So there is a one more we need to examine the circular should not be happened in the while process allocation state that time. Next one, the resource allocation state, when resources allocation state is defined by the number of available and allocated resources. The maximum depends of the process. So here what? Whenever the resource is allocating the states, that time we need to define the number of available allocated resources. Means we need to allotting the resources for number of processes. So how we can avoid this deadlock? So safe state is one more method is there. Safe state. So when process is request and available resources, system must decide immediately allocation level leaves the system in safe state. So here what happen? Whenever the process is request available resource, means the process want to execute some resources, that time the system must be decide immediately. Here the system must be decide immediately which how to allocate the resource and process immediately. That system should take care for that. Next one, so here avoidance algorithm is what here. The deadlock algorithm helps to dynamically assess the resource allocation state so that there never be a circular wait situation. Means here what, the circular should not be happen. For avoiding this deadlock avoidance, we can, there is a two types of resources are there. Two type means it's two instances. One is single instance resources type. In that a single instance resource, we using resource allocation graph. Second one, the cycles are necessary which sufficient for deadlock. So next one is the multiple instance of resource types. Cycles are necessary but never sufficient for deadlock. Means that should not connect to again and again for that resource. Next, use the Banker's algorithm. Using this Banker's algorithm, we can avoid the deadlock. For avoiding for first this, the safe state we need to state is here. The system is in safe state if there exists a sequence of, so number of processes are given here, P1, P2 up to Pn, of all the processes is system such that each pi the resource that pi can still request can satisfy by currently available resource plus resource held by the pj with j less than I. So this is the sequence which we need to follow in the safe state. Thus, that is, if pi resource needs that not immediate available, then pi can wait until the pj has finished. When pj is finished, pi can obtain need resources, execute return, allocate resource and terminate. When pi terminates, pi plus 1 can obtain it needed resources and so on. So these are the conditions we need to follow. So basic fact is what here. If the system is safe state, means there is no deadlock. If a system is unsafe state, possibilities of deadlock. Avoidance means what here? Ensure that the system will never enter an unsafe state. Means what here? Avoidance is what? Ensure that the system will never enter an unsafe state. So here, using this avoidance, we can avoid the deadlocks. So here, if the deadlock is happens, what are the disadvantages comes here? Means the delay process initialization means when the process is going to initializing, that time delay can be occurred because of here the process are getting needed to finding the resources. Then process, second one is the disadvantage. Processes must know future resource needed, further resources are needed. So next one is avoidance algorithm is means what here? The single instance resource type use a resource allocation graph. Multiple instance of a resource type means what here? We are using Banker's algorithm. So what the resource allocation graphs here? Set of V vertices V and set edge of E in the sense of edge. So V is partitioned into two types, P equal to P1 to up to Pn, the set consisting of all the process in the system. R equal to R1 plus R1 R2 up to Rm, the set of consisting of all the resources, types in the system. Request edge, here request edge is directed edge P1 process 1 to Rj, assignment edge directed edge Rj to Pi. So these are the resource allocation graph. Resource allocation graph, the process types of 4 instances. Request Pi request instance of Rj, then Pi hold the instance of Rj. So we can view the graph here, how this allocating the resource and instances. Next one, resource allocation graph algorithm. A process, suppose that process Pi request a resource Rj, the request can be granted only if converting the request edge and assignment edge does not result in the perform of a cycle in the resource allocation graph. So here is the one example of how the resource allocation graph. So P1 is holding R1 resource, but R2 is resource is holding P1, but same P2 is holding resource 1, again P2 is holding R3 resource 3, and resource 3 is holding process 3. So this is what example of resource allocation graph. So what is the Banker's algorithm? Banker's algorithm is what? Multiple instance, and each process must prior claim exam use. When a process requests a resource, it may have to wait. So it may have to wait. The process gets its resource, it must return them in finite amount of time. The structure of Banker's algorithm is, let n equal to number of processes and m equal to number of resource types. So available vector of length m, if available of j equal to k, there are k instance of resource types Rj available. Max into n into m matrix, if max ij equal to k, then the process Pi may request at most k instance of resources that are j. Allocation means what here? N into m matrix, if allocation ij equal to k, then Pi is currently allocated k instance of Rj. need n into m matrix. If need ij equal to k, then pi may k more instance of rj to complete its task. Need ij equal to max ij minus allocation ij. So here when we are going to find the need of that matrix, then ij equal to max ij minus allocation, then we get the need of that execution process. Safe state algorithm. Safe state algorithm, let we work finished view vector of length m and n respectively. Initially work equal to available, finish I equal to false for I equal to 0 to n minus 0 1 up to n minus 1. Find I such that both finish I equal to false, need to work. If no such I exist, go to step 4. Work equal to work plus allocation, finish I equal to true, go to second step. Finish, if finish I equal to true, then all I, then the system is in safe state. So here resource request algorithm for pi. The request is vector of pi kj equal to, then request need to, if the request needed, go to step 2, otherwise rise the error condition since the process is exceeds its maximum claim. If the request is available, then go to step 3, which is allocation equal to available minus request, allocation equal to allocation plus request. So need I equal to need I minus request I. If safe, the resource are allotted to pi. If unsafe, pi must wait and hold the resource allocation state. The state is resorted. So here is one example are given for bankers algorithm. So here what happened, the totally 5 processes are given and the allocation is given, maximum availables are there given, max is given, available is given. So we need to find the need matrix here. So what is the formula for need matrix here? Max minus allocation. So max minus, we need to find the allocation, then you will get the need here. So this is the summary of this session. So these are the references are given and below our website links are given. Thank you.